Something strange is coming from Proxima b, and it's not what you might expect. A planet just 4.2 light-years away is emitting light in a way that defies everything we know. Could this be a sign of alien technology? Proxima b isn't just another distant planet. It's a real contender in the search for life beyond Earth. Located just over 4 light-years away, it is one of the closest exoplanets to our solar system and shares some surprising similarities with our own planet. First, let's talk size. Proxima b is roughly similar in size to Earth, which is one of the reasons it has scientists so excited. But here's where things get interesting. While it might seem like a twin of Earth, it's orbiting a red dwarf star, Proxima Centauri, which is much smaller and cooler than our Sun. This drastically changes the environment. Now, the key thing to remember, Proxima b lies in what we call the habitable zone of its star, meaning it's in the right position where liquid water could exist. Water is essential for life as we know it, but while Proxima b might have the right conditions for liquid water, it's also dealing with some major challenges. The most significant is tidal locking. This means that one side of Proxima b is always facing its star, while the other side is in permanent darkness. Imagine living on a planet where half is scorching hot and the other half is freezing cold. These extreme temperature differences could make it harder for life to survive. On top of that, Proxima Centauri is known for its solar flares and intense radiation, which would constantly bombard Proxima b's atmosphere, adding another layer of hostility. So while Proxima b offers some tantalizing possibilities, it's far from an easy place for life to thrive. Yet, its proximity and potential for water make it a prime candidate for further study. Could life somehow survive in these extreme conditions? That's the question scientists are racing to answer. Red dwarf stars like Proxima Centauri are the unsung heroes in the search for habitable planets. They're small, dim, and often overlooked, but they are actually the most common type of star in the entire galaxy. And here's why they matter. These stars burn slowly and steadily for billions of years, giving any nearby planets the potential for long, stable conditions. Because red dwarfs are cooler and less luminous than our Sun, their habitable zones, where liquid water can exist, are much closer to the star. This means that planets like Proxima b, which orbit red dwarfs, have a chance to be within this sweet spot for life. The slow, steady energy output of red dwarfs might actually make these planets prime candidates for sustaining life over incredibly long time scales far beyond the Sun's expected lifespan. But there's a catch. While red dwarfs are stable over time, they tend to be more active than the Sun, frequently emitting powerful solar flares and radiation bursts. These outbursts can strip away the atmosphere of a planet or bombard it with harmful radiation, potentially making it difficult for life to develop or survive. Still, their sheer number and longevity mean that planets in their habitable zones like Proxima b offer a unique and exciting opportunity to explore the potential for life on distant worlds. In the search for habitable planets, red dwarf stars aren't just an interesting side note, they're central to the conversation. The search for life on Proxima b is one of the most exciting endeavors in space exploration today, but it's also fraught with significant challenges. At the forefront is the difficulty in studying such a distant planet. Proxima b orbits the red dwarf star Proxima Centauri, located over 4 light-years away from Earth. To put that into perspective, that's about 40 trillion kilometers, an almost unimaginable distance. Given this vast expanse, simply gathering information about Proxima b is no small feat. One of the primary obstacles faced by astronomers is the sensitivity of the instruments required to study distant planets. Traditional telescopes struggle to gather enough light from such far-off places, and they can't always separate the faint signals from Proxima b from the overwhelming glare of its star. More advanced instruments, like the James Webb Space Telescope, launched to study the infrared universe, and upcoming tools like Harmony on the Extremely Large Telescope, are designed to delve into these difficult-to-reach worlds. These telescopes offer new ways of analyzing distant planets by detecting light emissions, especially from their atmospheres, which could hold vital clues about their habitability or even the potential for life. But even with such advanced technology, astronomers face another serious hurdle: the nature of Proxima b itself. The planet's proximity to Proxima Centauri means it's subject to intense radiation and frequent solar flares. This radiation bombardment can complicate our ability to study its atmosphere and any potential signs of life. In addition, Proxima b is tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. This creates extreme temperature differences that make it even harder to predict whether life could survive, especially on the dark side, where temperatures might plunge to extremes. Despite these obstacles, the potential stakes of the mission couldn't be higher. If Proxima b is found to harbor life, particularly intelligent life, it would radically change our understanding of the universe and our place within it. It could answer one of the most profound questions in science. Are we alone? The potential discovery of alien technologies, hinted at by the strange light emissions detected from the planet, adds a layer of intrigue. These emissions could be natural phenomena, or they might point to something more extraordinary, like a signal from an advanced extraterrestrial civilization. To address these obstacles, scientists have taken a multifaceted approach. First, they've relied on existing instruments such as the Hubble Space Telescope to monitor Proxima b's environment and detect any unusual light emissions. The strange emissions detected from Proxima b's dark side, which have baffled astronomers, are being closely scrutinized. These emissions could suggest the presence of alien technologies, although they might also be the result of natural phenomena like volcanic activity or atmospheric distortions. The next step is to focus on analyzing Proxima b's atmosphere in greater detail, using more advanced spectrometers and space observatories. The James Webb Space Telescope in particular is expected to offer unprecedented views of distant worlds. Looking ahead, the challenges of studying Proxima b will only grow as we seek answers to these monumental questions. The distance will always be a barrier, but with the continuous development of more powerful telescopes and observational techniques, it's likely that we'll begin to understand more about Proxima b's potential for life. It's possible that in the future, we could send missions closer to the planet. But for now, astronomers will rely on the tools at their disposal to probe the planet's atmosphere, light emissions, and surface conditions. If scientists do manage to detect alien life or technologies on Proxima b, the implications would be enormous. Not only would it prove that life can exist in environments far different from Earth's, but it could also reveal technological advancements that challenge everything we know about space science and civilization itself. While these discoveries are still in the early stages, the path forward is clear. Keep pushing the boundaries of what we know and continue to unravel the mysteries of Proxima b. As we look deeper into Proxima b, the tension begins to rise. Imagine a planet locked in time, one side always facing its star while the other is trapped in perpetual darkness. This phenomenon, called tidal locking, brings with it extreme temperature differences, one side scorched by constant sunlight, the other frozen in shadow. The harsh conditions make the possibility of life seem distant, almost impossible. Could life survive in such an extreme environment? Could anything adapt to such extreme temperatures? But wait, there's a release. Proxima b isn't without its mysteries and wonder. Despite the inhospitable conditions, it's possible that the narrow twilight zone, the thin band between eternal day and night, might have more stable temperatures. Here, liquid water could exist, which is essential for life as we know it. This possibility alone makes Proxima b one of the most exciting planets for scientists to study. As we focus on these unique characteristics of Proxima b, we can't ignore the potential impact of its unusual dark side. The strange signals coming from the planet's hidden hemisphere add another layer of intrigue. Could these signals be coming from life, or could they be evidence of alien technology? The potential answers to these questions keep building the mystery, fueling our desire to understand this distant world. While the environment is challenging, the awe-inspiring possibility of what we might discover on Proxima b, whether it's alien life or technology, keeps us going. The answers, though elusive for now, could shift everything we know about life beyond Earth. The search continues with more questions than ever. What could we find next as we dig deeper into the mysteries of Proxima b? One question keeps resurfacing. Could this distant planet be home to intelligent life? The strange light emissions detected from Proxima b's dark side have baffled scientists, raising the tantalizing possibility that they could be a signal, a sign of advanced technologies, or even an alien civilization. Could Proxima b be the place where we first make contact with extraterrestrial life?